Hello everyone, my voice is clear or not? Hello everyone. I think it's showing my voice first. Or not? My voice is clear or not? Hello. I think it's showing my voice first. I think issue is resolved now. After six, after hello. Yes, voice is clear now. Actually, today I am going to uh, say you something about my lecture. Okay, how many topic I am teach to you. So here is some preface. So basically, I am starting with set and their basic operation, and then move on functions and their properties, types, countable, uncountable, sets, Cantor set, and then we move on next topic, which is point set topology. Then we are able to learn what is sequence of real number, series of real number, functions and their graph, limit continuity uniform, because this topic is very important, okay, for whether you are doing for preparation or you are move on class, okay. So any course. So my name is Divyansu Srivastava, and I am a JRF scholar in BITS Pilani campus, Hyderabad. So my aim is to teach you something more important, which is basically used in our higher education, or it's the content is help you to how to deal with this topic and how to deal with this subject real analysis and okay anywhere. So here is some more which is differentiability and their application, sequence of function, series of function, improper integral, Riemann integral, and then move on function of bounded variation and function of several variables. Okay, so just it is an introductory class. So I am in introductory class. I am teach you something, a lot of things about sets and functions, and other is point set topology. So my voice is clear or not? Introductory class. I am teach you something, a lot of things about. So I have a topic which is named as sets and function. So what is sets and function? Mainly why we study this topic here, because in class 12th in B.Sc in class 12th we study about the number which is related to something many basic fundamentals we already deals with, like whole number theory and other things, okay. So here is the set and function, the collection. Now I am going to teach this. So the collection of well-defined object is called set. And here is some say about the well-defined object. It means you have say a collection for such type of elements object which satisfy some rule. Okay. And it is possible to say that particular objects belongs to the collection or not. So I have a collection of a set which is the element from taking a z which is satisfy some equation. here is some equation is written. Now the format of this, I will take this equation by integer format. So I am taking x belongs to z such that these are the using for integer type. So mainly the collection of elements or collection of any things such as we put here the when we find the number. Now, first of all, you are getting some root here, and these roots are 1 minus 1 1 by 2. Okay, so when we put here 1, it gives you something 0. Okay, now come and put this. So what will you get? You get when you put here 1 ka cube plus 1 square minus 2 into 1 minus 1. Okay, so here is 2 plus 1 minus 2 minus 1. Okay, so everything is cut here. So you get when you put a px here and you put here x is equal to 1, then your output is 0. So these are the basic and you get a 0. But out of these only 1 and minus 1 belongs to integer portion, but it is the part of fraction portion which is a rational type. So which satisfy the given rule, and this gives you x should be the form of z. So this are satisfy this equation for using x is equal to 1 and minus 1. So what is your set is s is equal to 1 and minus 1 only. Okay, so that is you have one more example related to real number, and here is the taking x which is belongs to r such that x which is not equal to x. So what it means? It means you every element or every real number is always equal to itself. Okay, so there is no real number which satisfy the given rule. Hence this is the calling as a empty set. When the element are not equal, okay, then you are tell as the empty set. Okay, now come to the next point, which is equality of sets. So what is equality of set? Equality of sets is means you are getting a two sets said to be equal when you they consist of exactly same element. Okay, so exactly same elements when you getting a subs like set equal to a is equal to 1 comma 2, and b is also you are taking 1 comma 2 element type. So you are here the set are equal. So you says that it is a equal of the sets. Okay, because their elements are equal. Okay, same element. So this topic are done. Now subset. What is subset? Okay, so if s and t are two sets, what it means? It means ki you are getting s and t, these are two sets such that member of s is also member of t. Okay, now S is a subset of T and denoted as S subset T. These are the denote when you are using for denote sign, you are using this. Okay. So here that is it means ki X belongs to S, therefore imply X belongs to T. Now it is the part of subset. Okay, here is some note behind this. So note are, if X belongs to A, therefore imply X belongs to B. If there is Y belongs to B, but Y does not belongs to A. It means A is called proper subset of B, and proper subset is right like this. A is proper subset of B because here is taking a X. Okay, what it means? It means ki you are getting a X belongs to A type. You are taking a one element which is belong to a set A, and these are imply both imply X belongs to B. Okay, so, and there is one more element which is y belongs to B. So, but y is not a member of A, then the set A is called a proper subset of B, and write like this. Okay, now come to the next point. Note every set is subset of itself. Okay, so many important point for this. Here, every, what it means here. Wait a minute just. Okay, I think my system is Actually, I am install a lot of work here. So actually, my system is hang now, and it is not good. Okay, so wait some time. Just I am fix this. नजर लग गई क्या इसको किसी की भाई? Introductory class I am teach you something. Yes, I hope the content quality is clear now, na? Okay, okay, nice. Content quality is very clear. Okay. This looks a very clear content quantity. Actually, my system is hang. So after some time, I will teach you more. Okay. One more time, I am open this and okay. Finally, I open PowerPoint. Now move on my flow. Where I am? I am in. Yeah, here is one more. Okay. So here is these notes are very important. Okay. So I am talking you about this note. Okay. And you the note is say about a proper subset because here is when you getting a element x belongs to A and therefore imply x belongs to B. Okay. And one more element belongs to B and which is not a member of A. So I am saying you A is proper subset of B. Okay. So this note is very important for you. Now every set is subset of itself and one more is empty set is a subset of every set and another note is empty set is what unique. Now come to this paradox. Why I am teach you this paradox? This is a Russell paradox. Okay, it means a contradictory statement. Okay, Russell paradox and paradox means contradictory statement. And now I am going to explain this. What is Russell paradox? So there is no set of all set. Okay, there is no set of all set. Now you are taking a sum A and put a element here. X is a set where X which is not a member of X. So if possible, A is what? Set. So here therefore imply A belongs to A. But if any element belongs to A, say X satisfies some this. So here if A belongs to A and if not belongs to A, then you say that it is the contradiction. It gives you contradiction. Okay. So now contradiction is coming by taking a wrong assumption. Hence, there is no set of all set. Okay. What it means? It means if you a possible A is any set, A is any set, A is a set. Okay, and A belongs to A. It is possible or not you are taking a one set and you take a set as a element and A belongs to A and belongs to A. So A is say as X. Now satisfy X which is not belongs to X now because when you are taking a set complete set and X is a member of X. So here is the same element which is our X, but when you satisfy X does not belongs to X, so here it gives you some contradiction. So it is the very wrong part. Okay, it is a very wrong way to doing this. So now the paradox means it is a self-contradictory statement. Okay, one time my mother is calling me. Wait for some minute. हेलो, घर पे हैं, पढ़ रहे हैं, होगा नहीं, ठीक है. Okay, now move on the cardinality of a set. What is cardinality of set? Cardinality set, it is the calculating for the number only. And when we set the existing element, which is known as cardinality of set, we are the number of element. Okay, the number of element in any set A is called cardinality of A. When you denoted as card of A or mod like this, okay. So it is a card like this, okay. So here is some element. Here is some alphabetical element, vowel element, and what it says the cardinality. Cardinality, the number in a set. Okay, so it is the cardinality of set. Now come to the power set. What is power set? The power set of all subset of a- any set is said to be power set, and it is denoted by PS. Okay. So here is some power set are like this. When you're taking a S is equal to the element are P, Q, and R, then the power set are taking a number a complete S and singleton P, singleton Q, singleton R, and taking a one PQ and one more is PQR and then PR. So and also the phi. So what is power set? Power set is nothing but is it is the cardinality appears it is equal to the 8, which is possible power set is here. So we are write in format of 2 to the power q. So uh, if the cardinality set S contains n elements, then its power set will be contained as 2 to the power n elements. So cardinality of power set is what? 2 to the power n element. So here is some proof for this. Okay, I am not going to teach you some proof. I am going to the move on next topic. Okay. So it is Cartesian product. Cartesian product is nothing but by using when you take two sets A and B, the Cartesian product is denoted as A cross B and defined as here A, B, and A is a member of A and B is the element of B. So now their sets are A, B, C. You are when are taking three sets here, then the element are A from A, B from B, and C from C. Now, in general, the product of when you are taking this type of element for I times, where I is from uh, uh, I to N. So here is the product from I to N, AI, which is from by using A1 to AN. So now AN is the element A1 taking one more element, and these are the Cartesian product. Okay. So called the order of n tuple. Now here is some result are very important. So in first result, when you have a cardinality of A which is equal to m and product cardinality of B is equal to n, then when you taking a Cartesian product for this, then you will find this m cross n which is equal to m dot n which is are equal. Okay. Now one more result for this. You have these are the result already I am teach you. Now move on the second result. Um, when product of A cross B, which is both imply B cross A, if and only if A is equal to B. And move on third point. If A intersection B is equal to M, then their intercardinality gives you the M square. And point four is proper subset of B, which is therefore imply taking one more C, and it gives you a main proper subset only. These are the very important for you. Okay, read on my PPT. Now move on next part. Here is some union and intersection set. So I'm not going for this. I'm another part section. Here is this disjoint set. Disjoint set. हेलो। हाँ, यूट्यूब पे ऑनलाइन पढ़ा रहा हूँ। यूट्यूब पे ऑनलाइन पढ़ा रहा हूँ। लैब में है, यूट्यूब पे ऑनलाइन पढ़ा रहा हूँ। So now what is disjoint set? Disjoint set two sets A and B is said to be disjoint if they have no element in common. Means their intersection should be 5. So A or empty set, their intersection is null, that it is a disjoint set. Now come to the next node part. Every disjoint sets are distinct set, not conversely. You have some sets like S and T and taking an element like 1, 2, 3, 4, and here is T part 2, 5, 7, 8. So these are two distinct sets because their elements are different. So S and T are distinct but not disjoint because S intersection T, because here is some intersection part which is equal, such as 2 and 2, which is not equal to 5. So when you're taking these two set, they are not they are distinct but not disjoint because here in intersection is some, I have some point which is 2, not give you the intersection. We are when you are taking an intersection, not gives you an empty. Okay, so it is a not a disjoint set. Now move on difference of two set. So what is the difference of two sets? It means you are here taking as all element which are A but not in B. So these are the different of two sets. So difference are not commutative and difference not associative. Okay. Now move on the symmetric difference. What is symmetric difference? Here is taking x and y are two sets. Then a symmetric difference of sets x and y denoted as x symmetric y. So x symmetric y, which is equal to the difference of x minus y union y minus x. So here is the some intersection part. Okay. Actually, after some time, I'm going to home. Okay. Now function or mapping. What is function? The point is that now what is function? So function is nothing but when you're taking it is a rule. Okay, to assign every element of A to a unique element of B by taking a process, and here is the denote for this like this, and here is the part of domain, and this is the codomain. And here we study about many function one onto many one. Okay, onto surjective and bisective. These are using here the term. Okay, so function is nothing but you assign every element like this, taking a two part. Here is some set A which is domain A, and here is B. So here is the element 1, 2, 3, 4, and another element 1b, A, B, C, D. So you assign every element to every, you assign here the every element of A to the unique element of B. So these are the type of function for 1 1. Okay. So in 1 1, FA is equal to FB. Okay. And now move on the node part. Node part is AU. If you take a different domain for some rule f, then you can consider it as two distinct function. And the two distinct function like this, when you taking two different domain like this, here is A and here is C, and our codomain is same. So such that fx is equal to sin x, such that fx is equal to sin x, both the function are taking as an example here. So here rule for both for some fx is equal to sin x, but domain are different. That's why these two function are considered as the distinct function because their domain are different and codomain is same anything else. Okay, but these two are the taking as a two uh, different function. Okay, because they have different codomain. Now move on the next part, which is the node part for this. So two function f and g are equal if and only if their domain are same, and function fx is equal to gx when x belongs to domain. Now come to the next part, type of function. Here is one more type of function, which is our one function. So what is one function? The one function is nothing but when you taking a function from a to b, if taking element x1 and x2 belongs to a, they are same. So fx1 fx1 is equal to fxx2, and therefore imply x1 is equal to x2. And one another part, otherwise fx1 which is not equal to x2, and therefore imply x1 is which is not equal to x2. So these two format are function, and their mapping look like this. Here is your taking a function f is 1 2 3 4, and one another mapping a b c d e f type. Okay, and you see here there is gives you a unique element for each and every domain, and it's you are taking a codomain, because here is only the entry for the element is 1 2 3 4 are belong set A, one another set for B, and they are give you a unique image, so it is a one function. Okay, because here fx1 which is equal to fx2. Okay, now move on next part. Here is one-to function. And what is onto function? Onto function is nothing but function f belongs to a tends to be said to be onto function if each element of b has at least one pre-image. So it gives you here is the key point is that if each element of b has at least one pre-image in a under f, also called surjective function, onto function, their other name is surjective function. Okay, surjective function. Okay, so if function is onto, then their range f equal to b, and both are what type of function? Onto function. Okay, here is one example for f, and here is one example for g. These are onto function. Now move on second part. Here is into function. In into function, basically in into function, when you are getting some mapping from A tends to B is said to be into function if there is just one element in B which has no pre-image A under F. That is, a function F which is not onto is called as into. When a function is not onto, what it's called it as a into. That is, F mapping A tends to B is cannot be is an into function if a range there are not equal to codomain. So we're taking a one example for this, taking a F mapping R tends to R such that fx is equal to x square. Here for every negative real number of codomain have no pre-image in domain R under fx is equal to x square. When you check for fx is equal to x square, uh, uh, there is no pre-image you get. So what it's called? It called as a into function. Okay. Now move on next part, which is many one function. A function f mapping A tends to be set to many one function if two or more than two element of A have same image in B. So two and what it means when you get a map here. Here is the domain part is A and codomain part is B. Many one function is like this: 1, 2, 3, 4 type element A, B, C, D. You are getting many one function. Okay, so here is mapping f mapping A tends to be many one function if x1 and x2 belongs to A, such that x1 not equal to x2 and fx1 is equal to fx2. So you are taking these are many one function. Now move on many one into function. So many one into function is nothing but is set to many one into function if many one and into function as well. Okay, move on next part, many one onto function. These are the functions which is basically used in function part. Here is some identity function, and identity function is what? A function f from set X to itself such that every element mapped with itself, then you says that it is identity function. Okay. Now move on. Bijection. What is bijection? A function f is called as bijection function if it is 1 1 and on 2. In bijection, 1 1 and on 2 is necessary for bijection. Take a mapping, F mapping, it tends to be the range Rf denoted as range, um, denoted as range of F is denoted like this, or you are right like this, range of A. Okay. So defined as when you take a range of function which is equal to Fa. Okay. And here is entry for A. Now these results are actually we study in our next class because our next part is composition of function. Okay. Actually, I have no time to teach you. Study I am teach you in a manner way and not in fast way. Okay. So thanks for watching these videos. Meet you tomorrow.